and that is to find the sum of the sequences. So what I mean, does everybody recognize that this is a geometric sequence? Is everybody okay on that? Can everybody read that stuff? Do you understand what I'm saying there? Right? A1 is the first term, the next term is going to be multiplied by R, the one after that's going to be multiplied by R, and so on. Okay. So if I wanted to add all of them up, if I wanted to add all these terms up, and so on, up to the nth one, okay, then here's your formula for that. Here's your formula for that. Okay. All right, is everybody okay on that? Everybody get that down? Okay, you guys cut that? Not yet? Okay, let me pause this. So the sequence that we just did, okay, awesome, let's get on track here. Zach, let's get on track. So the sequence that I just gave you, awesome, Myra, it's called a finite sequence. It's got a finite number of terms. And then you get a sequence, a geometric sequence that might be an infinite sequence. In other words, it goes on and on and on. Like, for example, here, it's telling you that it's going on and on and on. It doesn't end at the nth term. Okay? So remember from the previous slide, our sum of a geometric sequence was something like this. Right? From the previous slide. Right? So in an infinite sequence, if this condition is met, everybody understand what that condition is saying? What's it saying?
That
R is less than 1? Yeah, so it could be, for example, minus a half. R could be minus a half. And its absolute value is less than 1.
So it can't be like 2.
Cannot be 2, cannot be 1.1. Cannot be 1.0001. Cannot be 1 either. It's got to be strictly less than 1. Yes. So in other words, if you're looking at the number line, it means that R has got to be between these values only. Okay, that's all it means. Now what I'm saying is that if that condition is met, then this formula becomes that. Is it kind of obvious to you or not really? Because remember what's happening to n in an infinite sequence. Where is n going to go? What does it become? Infinite. Okay? So what you're going to get there is, for example, you're going to get 1/2 to a huge number. Right? Now get your calculators out and experiment. Okay? What's 1/2 to the 20th power? What's 1/2 to the 200th power? And compare those numbers. See what's happening to it. Okay. So I'll do the first one, you do the second one, okay? So this is not an infinite sequence, okay? And the formula I'm going to use is this one here. What's A1 equal to? 64. What's R equal to? -1/2. And then you just go plug check that.